All right, in statistics today we're looking at normal distributions, and we're going to be finding values of these normal distributions. Okay, so number one here, use the standard normal table to find the z-score that corresponds to the cumulative area of 0.8916. So we've got this. This is the area under the curve. In other words, we've got this curve, okay, and we've got all this right here, this area to the left of this z value, whatever this z value is. All this area inside is 0.8916. All this area in here. Okay, what z-score gives us that area? All right, so what we do is we're looking for 8916. And that's what these numbers are here. These are the areas right here. And so it's not on this page because this one goes, this is the negatives for the z-scores, and it goes to 0.5. So here's the next page is where we're going to be at. See, these numbers get bigger. And we've got to find 8916. So 89, here's 8907. 8925. So it looks like 8916 is between these two right here, which this is, if you look at it, this is 1.23 and this is 1.24. So it's actually between 1.23 and 1.24. 1.23 and 1.24. So what we might do is we might say it's 1.235, which is halfway between those. But I believe if you put 1.23, I think it'd probably count that one. I don't see my answer on here. Yeah, but here it says right here. 1.235 is what the answer they go with. But I think it'll take you to one. Okay, so here's another one. This says use a standard normal table to find the z-score that corresponds to the cumulative area of 0.9500. So 0.9500. So again, what this means is we've got this, all this right here is colored in underneath the curve up to this z value. What's this z value? If all this area inside here is 0.9500. So I've got to look through the table here and find 0.9500, which it's on the second page again. And let's see, here's 97, and here, okay, look here. It's between these two values right there. See, 0.9500 is between those. So this is 1.64. If you, here, let me push down a little bit. See here? 1.64. And this one is 1.65. So it's in between those. Okay, so it's in between those, which means it'd be 1.645. See, 1.64, and then halfway to 1.65 would be 1.645. And so this is the value that we're looking for, and you can see right here, yeah, 1.645. Okay. Number 3, use a table again to find the z-score that corresponds to the given cumulative area. If the area is not in the table, use the entry closest to the area. If the area is halfway between the two entries, use the z-score halfway between the course. So it's got this right here, 0.054. 0.054. All right, now I think it's on this first page. 0.054. So 0.495. All right, look here. So look again, we're looking for 0.054. This is what we're looking for. Here's 0.548. Here's 0.537. So it's really between these two right here. Okay, so let's look over here. Over here we got 1.6, and then up here we got 0.1. Okay, so this one right here is 1 negative 1.61, and this one is negative 1.60. So it's between these two right here, negative 1.61, negative 1.60. So it'd be negative 1.605 in between them. Okay. So now it just took negative 1.61, and it didn't say. It says round to 3 places, but I think we're good there. I think we're good. Now number 4 here. Okay. Use a standard normal table to find the z-score that corresponds to the given percentile. Okay. If there is none in the table, use the entry closest to the area. If the area is halfway between 2 entries, use the z-score halfway between the corresponding z-scores. All right. So this says P2. Okay. P2. All right. Now, what that means right there, this means 2%. So you're in the 2 percentile is what this means. You're in percentile of 2%. So you're just looking for 2%, which is 0.02 is what you're looking for. Okay, so I look through here, and here's here's awful close right there, 0.02. So this is negative 2.05. And that's my z-score that gives me that percentile. Okay, so here you go. You can see the answer right there. See, we got it right. Okay, same thing here. Now this says P78, so we want to be in the 78th percentile, 78%, which means that's going to be 0.78. So I want to find this percent in the table. Well, it's going to be on the second page, because these numbers, the first page is negatives, which is 5 and below, 0.5 and below. These are positives, which is 0.5 and above. All right, so I just look on here and find 0.78. So, okay, here we go, right here. It's between these two right there. Okay. Which actually is closer to this one. See, this is 7794. This is like 6 10,000ths off. So it's really closer to this one. So this is, if you look at the side here, if I come over this way, that's 0.7. And up here, this is 0.7. So this is 0.77. Okay, which is what the answer is. Okay, so we're just looking at these values. Now this right here, P25, means it's the 25 percentile, which is 0.25%. So that's what I'm looking for, 0.25. All right, that's going to be on this first page, and let's see here. All right, here's 2 5s. All right, here you go, right there. It's between these, which this is 17 away from 2,4, and this is 14 over, so it's really kind of in between those exact. So this is negative 0.6, negative 0.6, and if I come up here, that's an 8. All right, so this is an 8, and then negative 0.6 on this one. If I come up here, that's a 7. So it's between these two values, which is negative 0.675. And that's what that would be. This is negative 0.67. Now this is programmed. It'll take negative 0.68. It'll take negative 0.675. It'll take all 3 of these answers. Okay. Now on this one, okay, find the indicated z-score shown in the graph to the right. So we've got Okay, look here. So here's what we're talking about. Here's my area right here to the left of that, which is what we want to do now, because see, our tables are to the left of that value. So what's this z-score if I have that area? So I'm looking for 0.1867. All right, so I've got this previous one we looked at here to see. 0.1867. Okay. Right here. But there it is. 0.1867. So that's negative 0.8. And if I come up here, that's a 9. So negative 0.89. And which, there it is right there. Okay, what about this one? Find the indicated z-score shown in the graph to the right. Okay, all right, look here. Here's my z-score right here, but see, this is shaded to the right of it. Okay, and this is my area, which means now that my tables are this part over here to the left is what our table is. So what I need to do is I need to take that 0.1190 and I need to do 1 minus this. So I do 1 minus this, which is 0.8810 when I subtract this. Okay, and so this is what I look up, because see, that's this part to the left is what the tables are. The tables are to the left of the z value. So since I want this to the right, I got to subtract it from 1, and then I look up that value there. So I'm going to look up 0.8810. All right, so here, let's get this other table. 0.8810 is on this one. 0.88, there it is, right there, 8810. So this first is 1.1, okay, and then right here that's 0.08. So that should be 1.18, which is what the answer says right here. Okay. All right. Find the indicated z-scores shown in the graph here. All right. Look at this. We've got a z-score here and one there. And let's see here. All right. So right down this dead center, this is 0.5. Okay. Now I want this z-score, which means I need to figure out what's to the left of it. So if I do 0.5 and I minus this 0.4750, okay, that's going to be right there. So this area right here is this, which is what I need for my table. See, the table is always to the left of that z-score, and see, this is to the right here, all this. So I need to look up 0250. So here it is, right there. Okay, so this is negative 1.96. Okay, so that's my first one, which is what we got right there. See it, negative 1.96. The other one should be positive 1.96, but let me show you how to do that, okay? Now, okay, so like what I did here, this is 0.5 right there down the center. So to the left is 0.5. So if I add this 0.5 plus 0.475, I get 0.975. And see, this was all that's to the left of it, 0.975. So I looked that up. And let's see here, 975 right there. So this is 1.96, which is what we just saw a while ago. Okay. Number 10. Find the z-score that has 40.9% of the distribution's area to the left. All right, so if I change it to decimal, it's going to be 0.409. So I look up this on the table. That's to the left, so I don't have to do any changing. So 0.409. Okay. So 0.4013 right there. Okay, I guess that's the closest we're going to get right there. So that's negative 0.2. And up here, 5. So negative 0.25. That would be my answer here. Wait a minute. Wait. I didn't see here, man. Right here. Here it is right here. 409. Okay, so that's negative 0.23. This one's going backwards, so it kind of confused me. This goes from 9 to 0 instead of from 0 to 9. I'm used to going another way. So anyway, so 409 is negative 0.23, which is what the answer is. Okay. Number 11, find the z-score that has 71.2% of this ratio to the right. Oh, okay. Look here now. We've got the bell curve, and we've got a z-score that has all this to the right, 71.2%. Okay? Now, our table is to the left. So we got to figure out what this is to the left. So that's really easy. I'll just do, this is 0.712. I just do 1 minus that, which is 0.288. So that's this part right here, 0.288. That's this part over here. This part over here is 71.2% or 0.712. And then this over here is 0.288. So 0.288 is what I look up. 0.288. Okay, let me see here. Okay, here we go, 0.288. Okay, here's 0.2877, which is 0.288. It's almost at 0.288. So I'd say negative 0.5, and this is 6, negative 0.56, which is what that is right there. So good deal. Okay, find the z-score for which 88% of the distribution lies between negative z and positive z. Okay, so what that means is, right here's a center, and this says 88%, which means if I divide that by 2, that means over here, this is going to be 44%, and this over here would be 44% on each side of that. So I want these z values that contain those. Okay, so I need the z-scores for the area to the left. So this area to the left here, what's this area right there? Okay, well, since this is down the center, this is 0.5, and I subtract this, so I do 0.5, subtract 0.44, which is 0.06. So that's my area over here. This area is 0.06. So I look that up on the table, 0.06. All right, so 0.0, 0.02, 3, 4, 5. Okay, here we go. It's between these two right here. Okay. 0.06, it's 594, and then here's 606, and they're equally the same distance away, so it's right in between those. Okay, so negative 1.55, negative 1.56, negative 1.55, negative 1.56, it's in between those, so you could do negative 1.555. But I think it would take either one of these three. If you look at the answer, it says negative 1.55, which means that'd be positive 1.55. When you're between a z-score and it's between those two and it's equal on the same amount, they're just going to be opposites of each other. But you could look this up the same way. This z-score here, we'll see it's 44% above the mean. So I do 0.5 plus 0.44, which is 0.94, and I look up that area. So 0.94 is between these two right here, which is 1.55, 1.56. So just like we had said a while ago. Okay. Find the z-score for which 3% of the distribution's area lies between negative z and positive z. Okay, so that means I've got this bell curve right down the center is my mean, which is 0.5. Well, that's not my z-score. This means this over here is 0.5. Okay. So since this is 3%, if I divide that by 2, that means I've got 1.5% here, and I got 1.5% there, because it's only 3%. Okay. All right, so that means if I do 0.5 and then minus, this is 1.5%. Just 1.5% would be 0.015. So here's what I got to look up. I'm sorry. I got to do 0.5 minus that. Which is going to be 0.485. And here's what I look up. Okay, so again, we got to have to the left of that value. So to figure out what the left of this is 1.5%, which is 0.015. I got to subtract that from 0.5, because see right here to the left of that's 0.5. So do 0.5 minus 0.015, which I get this right here, and this is what I look up. All right, so 0.485. Okay, 0.484 right here is pretty close. So this looks like negative 0.04. Okay, which I think we got it right there, man. And usually, like I said before, when it's between this certain value on both sides, it's going to be positive, negative. So negative 0.04 and positive 0.04. But again, if you don't know that, to the left of this one, I'm going to add this to 0. So I'm going to do 0.5 plus 0.015, which is 0.515. And so I look that up here. 0.515, which is right here, man. Positive 0.04. Okay. All right. We're making some progress. We're on number 14 now. In a survey of women in a certain country, the mean height was 64.3 inches with a standard deviation of 2.95 inches. Answer the following questions. What height represents the 95th percentile? Okay, so we want the 95th percentile. Okay, which means 95%, that's 0.95. All right, so if I look that up, which is going to be over here. Okay, this looks like it's right here between these two. So I'm going to go 1.64, and this is 1.65, which I'm going to say 1.645. All right, that's my z-score. Okay, 1.645 is my z-score. Now, let me come back here now, okay? All right, so if we're 95, that's my my z-score for this 95 percentile is 1.645. So that means right here, my z, remember, my z-score equals the x minus the mu divided by the standard deviation. Okay, so we looked up this 95th percentile, and we got this 1.645. That's my z-score. Okay, I'm trying to figure out what this x-score is that makes this work out. My mu, it tells us up here, the mean height is 64.3. That's average. It says the standard deviation is 2.95. So I've got this little equation right here. I need to solve it, do a little algebra. Okay, which means I'm going to multiply both sides by this 2.95. That makes this cancel off. So I've got 2.95, let's punch this in, 2.95 times 1.645. And that gives me this right here, 4.85275 equals x minus 64.3. Okay, and so I plus the 64.3 on both sides. And so if I do 4, all right, so I got the 4.8 on there, so I'm just going to go plus 64.3, and that, oh crap, I made a mistake. Okay, 4.85275 plus 64.3, and I get this right here, 69.152, which this is the height that would put you in the 95th percentile. 69 point, there you go, 15, we got it, 69.15. So in other words, average height is 64 inches, 64.3 inches. What height is going to make you be in the 95th percentile? That means your height is taller than 95% of the people. So you change the 95 to a z-score, is what we did right here, and you set up this little equation. Okay, and you got to solve and figure out what x would be to give you that percentile, which is this right here. All right, look at part B. The height that represents the first quartile is what inches? All right, the first quartile. Now let me explain that real quick. All right, you've got this bell curve. Right in the center, this is your average or your mu. Okay? Now, we call this the second quartile. Now, the first quartile is over here. And the third one's over here. Okay? So, this is 50% right here. All right, this is 25%. And this over here is 75%. And that's what our quartiles are. All right, so this is the height that represents the first quartile. So if you're in the top 25%, what would your height have to be? Okay, so first of all, I do 0.25, and I got to look that up to find out what z-score gives me that percent. So I'm going to look up 0.25. Okay, it's on this one. 0.25. Okay. I think it's right there. Negative 0.67. There's my z-score. So this z-score gives me an area of 25. See right there, negative 0.6, and that's the 7 up here. See? So this is the z-score that gives me the percentage of 0.25. Okay? So now what I can do then again, I can make me up a little equation, because z, I'll do right here, z equals x minus mu divided by standard deviation. So my z-score here, we just figured out, was negative 0.67. I don't know what this x value is, but we're told in here that the mean was 64.3, and the standard deviation is 2.95. So I put those in, and I just want to solve this equation here. So the first thing I'm going to do, I'm going to multiply by 2.95 on both sides to make this cancel off. All right, so I've got 2.95 times negative 0.67 1.67. And that gives me this right here, negative 1.9765. There you go, that's gone, so I just have this. And so now I add 64.3. And then x equals it right there. So, plus 64.3. All right, so that means 62.3235. Okay. So this is what the height is that would put this person in the 25th percentile. 62.32. And we got that right here. See there? We're good. Okay, we'll do a couple more of these. And in a recent study on world happiness, participants were asked to evaluate their current lives on a scale of 1 to 10, where 0 represents the worst possible life and 10 represents the best possible life. The mean response was 54, so there's my mean, or 5.4. And the standard deviation, 2.4. Okay, what response represents the 91st percentile? Okay, so the 91st percentile means that's 0.91. So look up this percent on the table. So 0.91, okay. Right here, that's right at it. 0.099 is 0.91, which is going to be 1.34. 1.34. Okay, there's my z-score for that. All right. So what that means is now my z-score equals x minus mu divided by theta. I'm sorry, divided by sigma, standard deviation. So we said this was, 1.34. It says my mu is 5.4 divided by my standard deviation, which is 2.4. Okay, so there's how I set it up. And now I just solve this. So the first thing I do is I multiply both sides by 2.4, which makes this cancel off. All right, so 2.4 times 1.34, 3.216. And here we got x minus 5.4. So now I add 5.4. And then, let's see here, 8.616. All right. So what that means is 8.616, which rounds up to 8.62. Okay. So that means 8.62 is the score that puts somebody in the 91st percentile. 8.62. So we're doing from 0 to 10. 8.62 would put you in the 91st percentile. Choose a response that represents the 60th percentile. So that's 0.60. Okay. So if I look up on the table, 0.60 is right here. This is actually closer, 0.25. This is my z-score, 0.25. So just like I did previous, I will set this equation. The z-score equals x minus mu divided by sigma. Okay, the z-score we just said was 0.25. This is my mu is 5.4, and the standard deviation is 2.4. Okay, and so I just solve this equation. So the first thing I do, I got to multiply by 2.4. this cancels off. So let's see here. 2.4 times 0.25. 0.6. All right, so this is x minus 5.4. So I need to add 5.4 to both sides. This goes away. And this is 6.0. So there's what x have to be. So what this means is 6.0 would put you in the 25th percentile. All right, so that means like someone that has a scale of 6, that puts them in the 60th percentile. So we got 6. It says 6.01. But I think it would take a 6.0. What response on this puts you in the first quartile? First quartile would be 0.25. So I look up that percent. Okay, so 0.25 looks like it's between these two right here. So it's negative 0.68 and 7. So negative 0.675. So there you go. There's my z-score that makes that percentile. Okay, we'll do that again here. Negative 0.68 and 7, so it'd be 7.5. So we're good. So there's my z-score. That puts us in the first quartile, 25th percent. So I do my z equals x minus mu divided by sigma. All right, so my z-score is negative 0.675. The x value, I don't know. The mu, it tells us, is 5.4. Standard deviation is 2.4. Okay, so I solve this. So I multiply both sides by 2.4. And make this cancel off. All right, so I've got 2.4 times negative 0.675. That comes up to negative 1.62. Okay, and so I add 5.4. And x equals, all right, 3.78. So I mean, someone that selects 3.78 as their rating on the quality of life, 3.78, either 3.78, that would put them in the first quartile, the first lowest 25%. Okay, we got a few more of these. 16. All right, the undergraduate grade point averages of students taking an admissions test in a recent year can be approximated by normal distribution as shown in the figure. What is a minimum GPA that would still place a student in the top 5% of the GPAs? The top 5%, which means if I do 1 minus 0.05, that's the 0.95%, 0.95. Okay, because see now, look here, in this thing here, the top 5% is this, okay, up here. All right, well, our graph, our tables are to the left, so I need all this over here, which means I got to do 1 minus that, which all this area here is 0.95. So that's my area, so I need to find the z-score for that. Okay, so 0.95 right here between these two. So that's 1.64, 1.65, so 1.645. So that's my z-score, okay? So z equals 1.645. So I gotta set up my equation again. Remember, z equals x minus mu divided by sigma. So this is 1.645 equals my x value don't know minus my mu, which it tells me that over here, 3.4 divided by 0.19. Okay, and so that's how I set it up. So I multiply both sides by 0.19. This will cancel off. So 0.19 times, oops, went off. 0.19 times 1.645 equals 31255. Okay, so I add 3.40. So this is going to be what's right here? 3.0875. So we didn't get that. This is 3.7. So let me look and see if I did something wrong here. All right, to be in the top 5%, that means it's 0.95. So 0.95 is right here, 1.645. So 1.645. Let me see if I... Okay, got 31255. I don't know. I didn't get the right answer on this one. I got 3.08. Oh, I thought that was a negative. I thought that was a negative, so I subtracted. I need to add them, so that's where I messed up. I'm sorry. So it's 0.31255 plus 3.4, and there it is, 3.712. So 3.71. That's where we're supposed to be. Okay, I thought it was a negative. I wrote there and it's a decimal. Okay. So that would put us, so what that means is, what this means is, this GPA right here would put this person in the 95th percentile. So you have to make that GPA 3.71. All right, part B here. The middle 50% of UGPAs lies between what and what? Okay, the middle 50%. All right, let me get a piece of paper here for that. Well, we got some room down here. Let's use this room. All right, so first of all, our z-score equals our x minus the mu divided by standard deviation. Okay, so we're going to use this equation. All right, now, the middle 50% means, well, right here. This is the middle 50% right there. Okay, these two right here. Which, if that's the middle 50%, that means I'm 25% this way, and I'm 25% this way. Which, that puts this one at 0.25, and it puts this one at 0.75. Okay? So I just look these up. Now, what we're going to do here is we're going to cheat, because remember, when you're in the middle percent, these numbers are just opposites of each other. So all I'm going to do is I'm going to look this one up, and well, it doesn't. My z-scores should be opposites. So I'm going to look this one up, and that would just be the opposite. So 0.25. Okay, so 0.25 here. is negative 1.96. Okay, here, negative 1.96. So the 25th percentile has a z-score negative 1.96. So it means my z here, negative 1.96. All right, that means on this one, this is going to be positive 1.96. So for that one, I'll do positive 1.96. Okay. Now what's the x-score here minus my mu? My mu is 3.4 divided by my standard deviation, which is 0.19. So this is going to be x minus 3.4. So I got to do both of these equations. So since it's the middle percent, once I find this percentile, the other one's just the opposite. So since it's negative 1.96, this has to be positive 1.96. All right, so I'm going to solve this one. So I'm going to multiply by 0.19, both sides. That makes this cancel off. And so if I punch this in, 0.19 times negative 1.96, and that comes out to negative 0.3724. So I add 3.4. And that comes up to 3.0276. Okay, we're not getting 3.27 like we're supposed to. Come on, Dave, making mistakes. All right, the middle 50%, that's going to be 0.25 and 0.75. So 0.25, looked up, negative 1.96. So let me multiply that again, negative 0.3275, and then I add 3.4. Yeah, I don't know. Let's do this one, see if we get it right. So I'm going to do positive 1.96 times 0.19. And I get 0.3724 positive, and then I add 3.4, 3.77. Okay, I'm not getting it. I'm not getting these. The middle 50% is 0.25 and 0.75. And I looked that up, 0.25. 0.25 is there, negative 1.96. Negative 1.96. And so I multiply both sides by 1.9. We got these numbers right. This is supposed to be, mu is 3.4, and the sigma is 0.19. I don't know. I don't know, we're making a mistake. I have to check on that one. I'll get back with you on that one instead of spending all this time on it. Okay, look at number 17 here. The weights of bags of baby carrots. I love baby carrots. The little bitty carrots. Anyway, the weights of those bags are normally distributed with a mean of 29 ounces and a standard deviation of 0.36 ounces. In other words, when you buy these bags, they're not exactly 29 ounces. They're going to be a little bit more or a little bit less probably. Bags in the upper 4.5% are too heavy and must be repackaged. So if they weigh in the top 4.5%, then they're going to dump them out of the bag and redo them. What is the most a bag of heavy carrots can weigh and not need to be repackaged? Okay, so if it's in the top 4.5%, which is 0.045, that's the top 4.5%. Okay, which means in the little bell curve, that's up here. Okay, well, I'm going to have to do 1 minus this because our table goes to the left. So I need to do 1 minus 0.045, which comes up to 0.9 There it is. So that's my percent. So I gotta look up that z-score. All right, so 0.955, 0.955. Ooh, right here, man. This is real close right here. All right, so that's going to be 1.7 straight up, 1.7. So this has a z-score of 1.7. Okay, so now I'm going to use this equation. Z equals x minus mu divided by sigma. This is my z-score, which is 1.7. The x value, that's what I'm wanting to figure out. My mu, it tells me right there, is 29. And then the standard deviation is 0.36. All right, that's how I set it up. So I'm going to multiply both sides by 0.36. That makes this cancel. So 0.36 times 1.7 is 0.612. 0.612 equals x minus 29. So I need to add 29, and it's going to be 29.612. And this is what x should be. So anything that's over that is going to get rejected. And let's make sure we get this right. Yep, 29.61. So anything over that gets rejected, rebagged. Anything under that is acceptable and it goes on to the market. Okay. Number 18. A mechanic sells a brand of automobile tire that has a life expectancy that's normally distributed with a mean life of 31,000 miles. That's the mean. And a standard deviation of 2,700 miles. He wants to give a guarantee for free replacement of tires that don't wear well. How should he word his guarantee if he's willing to replace approximately 10% of the tires? Okay. All right, so what this means here, he's going to replace the 10%. So like here you go. Here's the average right here. Okay. If he's going to replace 10%, well, ones that go beyond average, he's not going to replace them. The 10% is down here. This is my 10% right here. 0.10. This part right here. It's these tires that don't wear well and don't last very long. That's the one that's going to get replaced. So I look up this 0.10. Okay, looks like it's right here. 0.10, which is negative 1.28. So this has a z-score negative 1.28. That's my z-score. Okay, so that means in my equation, z equals x minus mu divided by sigma. My z-score, negative 1.28, equals x minus my mu, which it says right here is 31,000 miles. This is 2,700 miles. What this means now, most tires rather, can take 31,000 miles on average. If you get more than 31,000, you've got more than average. If you got less, well, then you're less than average. So I want to solve this little equation right here. So I'm going to multiply both sides by 2,700 to make this cancel off. So we got 2,700 times negative 1.28 equals x minus 31,000. Okay. So 2,700 times negative 1.28, that comes up to right there. Okay, so I'm going to add 31,000. And so, oops, messed up. It comes up to 27,544. Okay, which we're right at it, man, 27,540. So if it gets less than that on the mileage, they're going to replace them. They're going to replace the tires if it gets less than that mileage. Okay. All right, number 19, I think, is this the last one? I believe this is the last one. Okay. In a large section of statistics class, the points for the final exam are normally distributed with a mean of 68. So here's my mean. And a standard deviation of 7. So there's my standard deviation, 7. Grades are assigned such that the top 10% receive A's, the next 20% receive B's, the middle 40% receive C's, and the next 20% receive D's, and the bottom 10% receive F's. Find the lowest score on the final exam that would qualify a student for an A, B, a C, and a D. Okay, so it might help if we just draw this out. Okay. All right, the top 10% receive A's. So like this is going to be 10% here. These are my A's. Okay. The next 20%, so like so that'll go here. 20% B's. The middle 40, so this is 40% here. They're going to get C's. And the next 20%, that's your D. And then the bottom 10% is your F. Okay, now I have had college professors that do this. Your score is based on what everybody does in the class. It's not based on a certain grade, it's just based on how well everybody does. Okay, so now let's get my numbers here. So like this percent right here, this is 10%. This percentile right here, that's 10 plus 20, this is 30%. Then right here, this percent, 10 plus 20 plus 40, that's 70%. This one right here be 90%. And then at the end would be 100%. So these are the quartiles, or not the quartiles, but the separation values. All right, so the lowest score that would qualify a student for an A, all right, that's 90%. So I look up that percent to get the z-score. Now remember, I'm going to do this right here. Z equals x minus mu divided by standard deviation. So I want to look up 90 percentile, see what z-score that has. I know I'm wanting to figure out the x. I know my mu is 68. And I know my standard deviation is 7. I need to figure out what that z-score is. So I look up 90%. All right, so 90%, 0.90, right here. That's going to be 1.28. Looking at the table. Okay, get it here, line up. 1.28. So this is 1.28. And then I solve that equation. So the first thing I'm going to do to solve this, I'm going to multiply both sides by 7. That makes this cancel. So 7 times 1.28, 1.28 times 7 is 8.96. So 8.96 equals x minus 68. Okay, so if I add 68, it's going to be 76.96. And that's the lowest score you can make to have an A. And it says round to the nearest integer, so that'd be 77. 77 is the lowest you can make. And there you go, 77 is right. Okay, what's the lowest score that would qualify you for a B? All right, so if you look at B, the lowest B is right here at 70%. So I look up 70%. Now again, I'm going to do this right here. Z equals my x value, whatever it is, minus your mu, divided by the sigma, standard deviation. All right, now I don't know the x value, but this mu value was 68, and this sigma 7. What's my z-score for 70%? See, 70% is the lowest you can make to get a B. So look up 70% of the table, so 0.70. 0.70 right here between these two. 0.52. 0.52. So there it is. Put 0.52 in there. Okay. So now I solve it. So what I do to solve it, first thing I do is multiply both sides by 7 to make this cancel off. So 7 times 0.52 is 13. Oh, I hit divide. 3.64. So 3.64 equals x minus 68. This one I add 68. And that's going to be 71.64, which is 72. Rounds up to 72. So 72 is the lowest you can make, and sure enough, 72 is right. Okay. All right, now you get a piece of paper here. What's the lowest you can make to make a C? All right, here's your C right here. The lowest you can make right here, that's in the 30 percentile. All right, so I look up 30%. Now again, we're going to do Z equals X minus mu divided by standard deviation. Okay. This is what we're going to do. So I know this is X minus mu, which was 68, and this is 7 down here. Now we got to look up the Z score for 30%. So 0.30, 0.30. 0.30. It's right here, 0.30. So it's negative 0.52, negative 0.52. Okay, and now solve this. So first thing we do is multiply both sides by 7, which makes this cancel over here. So it's going to be negative 3.64. So I'm going to add 68. And so 64.36, which is 64. Round to 64. So let's see here. The lowest we can make to get a C, well, it says 65. I might have rounded wrong. Let's see here. Well, I will tell you this. When I got my Z score, let me go back to my Z score here. It's really between these two. So it's 0.3, so negative 0.53 and negative 0.52. Here's me write it down here. It's a negative 0.52, negative 0.53. So it's in between those, so I'm going to do negative 0.525. So I probably should have done that, negative 0.525. But I think it probably would count as 72. I think it would. But 7 times 0.525. Okay, and then it gives me I lost where I did this at. Here it is. I'm still getting 64. I think it would take it though. I think it would take it. If not, you just let me know. And then the last one, I just do the same business. This is wanting the lowest score to get a D. To get a D, that means you're in the 10%. So you look up 10%. Let's see here, which is 0.10. All right, right here. There's the closest right there. Negative 2.33. Okay. So again, negative 2.33. It's going to be your Z score equals your x minus your mu divided by standard deviation. So there's my z-score. I want to find out what the x-score. The mu was 68, and this is 7 down here. All right, so again, just like we've done the whole time, we'll multiply both sides by 7 to make this cancel off. So I have 7 times negative 2.33, which is negative 16.31. Okay, and so I'm going to add 68 to both sides, and I get 51.69, which rounds 52. And I didn't even see if that value was going to go. This is 60. Oh my goodness, man. Look at my, this is supposed to be 10% right there, which is negative 1 point, oh, no. I did this wrong. This is 1.28. How did I get negative 2.33? I looked at something different when I wrote it down. This is negative 1.28. So, okay, so it's going to be 7 times negative 1.28, and then add 68, which is 59.04, which would be 60. All right, so I've made a mess of some of these, man. I've gone through there, but hopefully you do these and you'll get the hang of it. And I can't find my cover sheet, but anyway, we're using these tables and stuff, so if you have any questions, contact me. I'll try to help you all I can, and we'll get through this normal distribution. And I look to hear from you. All right, so have a good rest of the day. Bye-bye.